and lathe machining. In lathe machining, just only single cutter is used for removing the metals. Also, in the lathe machine or lathe machining, the workpiece is fixed, is rotate while the cutting tool is fixed. But in milling machine, the cutter is rotate and the workpiece is fixed. So this is the meaning of milling. So there is different type of milling machine. Um, this is the sketch for the milling machine. It's containing for the components of the milling machine is column, arbor, cutter, table, and saddle. Also the base and knee. There is a knee elevating handle and knee screw. This is a sketch for milling machine. The working principle of milling machine. So in the milling machine, as I told you, we have a cutter. This cutter is like a gear containing several teeth, uh, designed in a special design, as you see in this figure. So this cutter is rotate, and the cutting or the workpiece is feeded in the direction opposite to the direction of the rotation of the cutter. So when this workpiece is feeded in the against to the cutting edge, so the metal will removed due to the resultant force between them. So the metal is removed due to the resultant force. So this is the working principle of the milling operation. So milling operation, milling machine or is used for machining the metals in for different purpose, like cutting keys, keyways, slots, grooves, cams and gears, and thread. Also can use for drilling, boring, and other kinds of operation. Uh, it's sometimes used for welding. How we can use the milling machine for welding? So there is a type or of welding called uh, called friction stir spot welding. So in friction stir spot welding, a special tool is used for making heat due to the friction between the workpiece and the tool of that used for the welding. So this video is give you an idea or give you a first idea of the milling principle, how it's work. Please keep watching this video. So as you see, the cutter is rotate and it's fixed on the special arbor or the shaft. The workpiece is fixed on the table, and this table feed it against to the rotation of the workpiece. So the metal is removed from the surface of the workpiece, and we can get or produce it will produce a product with the required size. So this is the principle of milling. So the specification of milling, we can choose the milling machine based on these specifications, the size of the work table, and the maximum length of the language tunnel, cross and vertical feeds. Also the types of milling machine, the power of driver or driving motor, also the number of spindle speeds. So the most suitable machine is that which containing several spindle speeds. Then there is several types of milling machine. The most common type is limb milling machine and end milling or vertical and universal milling. So this is the blade milling machine, as you see in this figure. The cutter is fixed on the arbor in a horizontal direction, and the workpiece is feeded in the vertical direction. This is the principle or the sketch for the main components for the machine. The second type of machine is a vertical milling machine. So in the vertical milling machine, the cutter is in the direction orthogonal to the work table or the workbench, and the head of the vertical milling machine can be swiveling in angles, so can be swiveled for in different angle in purpose to machining the surface with the angle. So some of vertical machine, the table is swivel while the head is fixed. So there is two type of vertical milling machine. This machine is commonly used for end milling, profile milling, and also for face milling. This video give you you can see in this video about the working principle of vertical milling machine. As you see, the main component for the vertical milling machine, electric motor, head, spindle, cutting or cutting tool, cartridge, column, bit, and knee elevating handle, and knee screw or elevating screw. Sorry. So this is just a main components for the machine, vertical milling machine. There is several components which like gearbox, monitoring screen, and something like this. So as you see, the cutting tool is worked perpendicular to the surface or the the surface required for finishing. So the saddle is fixed on the guideways by special poles and nut. So this is the main principle, the working principle for the vertical milling machine. The third type is a universal milling machine. So universal milling machine is used for doing several jobs. And this is a sketch for this machine. It can be used automatically by using telescopic feed shaft. The system in this machine most commonly is poly-belt system. Now we are going to the basic milling operations. So the machines is different machines used for making milling operations. So there is several different of milling operations. This milling operations can be done by using any one of the mentioned machines. So from this operations, plane milling, face milling, angular milling, straddle milling, form milling, profile milling, saw milling, and end milling. This video show you the different type of milling operation. So please keep watching this video. So this is the plane milling. So in the plane milling, there are two types of plane milling. The first one is called up milling, and the second type is called down milling. So what the difference between them? When the workpiece feeded in the direction against to the rotation of the cutter, this operation called up milling. While when the workpiece is fitted in the direction in the same direction with the rotation of the cutter, the machining called down milling. So in the down milling, no need for complex system of gauge and fixture to fix the workpiece, because as you know, the movement is in the same direction. So no need for complicated fixture. And in these two kind of milling, the metal removed from the resultant force between them. So this is the two types. This is the down milling. The second type is face milling. As you see in the face milling, we have a special cutting edge fixed on the teeth of the cutter, and this special edge is used for the cutting, not the teeth itself for the solid cutter. So the direction is orthogonal to the work the surface, and this process is used for surface roughness or surface finish. This third type is straddle milling. In the straddle milling, we have two types of cutter fixed on the arbor and work simultaneously at the same time. So the distance between them can be controlled by the spacers. So this machine is save much time because there is two type of cutters work simultaneously at the same times. Gang milling. In gang milling, three types of cutter used or work simultaneously. Sometimes this cutter have different diameters. So to calculate calculate the speed of cutting by calculating the diameter based on the diameter of the large cutter. So also this type of milling save much time for operation. This type is form milling. In the form milling, irregular tool with irregular surface used for making convex or concave surfaces or grooves, as you see. End milling. This is the cutter for the end milling. It's like drilling machine, and it's used for making a vertical surface, also for narrow slots, grooves, and narrow keys. So it can be performed for, vertically or horizontally based on the reference table. Angular milling, a cutter with the angle used to make a groove with the angle. So this angle can be adjusted 45 and 60 degree and 90 degree. So there is two types, maybe single or double angle for making grooves with the single or double angle. This one is slot milling, T-slot milling. This used to make a slot like a T, but this process or this machining comes after end milling. So to make key slots by this special tool, as you see in this video. Also can be feed from any one of one of end of the machining. This is all about the milling operations. So here there is writing or explanation about the all types of milling operations, and there is figures and sketch to explain more. So please read carefully these explanations. And now we are talking about this video is talking about the types of milling cutters. Please keep watching this video. all about the milling machine and machining operations, and also types of cutters. Do you have any question? Hello? Do you have any question? Okay, so now I will show you how to operate the machine. Okay, guys, before you are going to machining or to operate the machine, please make sure that you wear goggles and safety clothes to protect yourself. Then you have to fix the tool post or the tool fixture uh, like this in the video. Make the bolts in these keyways on the table and make sure it's tightened. Then go to make an alignment by using special gauge. So do the alignment. After doing the alignment, you must fix the cutter or the cutting tool. So there is this is the method. Different machines have different design. So this not all of the machines like this in the video, but the same principles. So follow the same steps for operating the machines. So put the cutter on the spindle. Make sure the spindle is locked by using the key for the lock, and use the key to tighten the cutter. Make sure it's tightened. After that, open the unlocked or make the spindle free movement. Go to the speed. So here there is a very important thing you must know about it. So there is two types of speed system. The first one called gearbox system. In the gearbox system, you have different type of gears. This gears is engaged based on the speeds that we want. So the old machine doesn't have a clutch. So to change the speed for the machine, you must stop the machine or off the machine, then change the speed. If you will go to change the speed while the machine is during operation, you will cause damage or destroyed for the gears. So be carefully when you change the speed for the old machine. For the new machines, there is a clutch system automatically or magnetic clutch. so you can change the speed while the machine is running. So this is for the speed of the machine for the first type of speed system, which is called gearbox. Second type of speed system called poly belt system. So in the poly belt system, there is several there is a pulleys and driving. So to change the speed, if you want to machining soft metals like alumina, so the soft metals doesn't need for the high power for machining, so because it's easy to cut. And for these soft metals, you need a high speed with the low power. So if you want this, go to the box for the poly system and change the belt for the large diameter in driver and small diameter in driving. So you will get high speed with the low power. If you want high power with the low speed, you must change the poly from the low diameter in the driver and high diameter in the driving. So you must follow this. There is a mathematical formula used to calculate the speeds want for the machining of the metals based on the metal hardening. So the soft metal needs can be machining with a high speed and low power, and the hard metals need high power with the low speed. Because if you machining the hard metal with high speed, you will cause early damage for the or immediately damage for the cutter, and also maybe cause change in the microstructure for the metals due to the high temperature which resulted from the high friction. So please be carefully when you choose the speed. So refer to the mathematical formulations to calculate the required speed based on the metal that you are going to machining. So this is the way for changing the belt. So lost the poly belt system and change the belt from to the required diameter and close the cover. So after that, go to fix the workbase. So please, before you fix the workbase, make sure that the workbase is clear. You have to make it clear and then fix it, make it tighten or properly fixed, and you must make a gap between the workbase and the rotating cutter before you go to run the machine, because if they are in touch while you run the machine, so you will immediately damage the cutter. So make sure there is a gap between them before you run the machine. So now the most important thing is how to get the 0 point. Here, before you go to select or get the 0 point, make sure if you run the machine clockwise or anti-clockwise. So this selection is based on the design of the cutter. So some the cutter is designed to work in clockwise and some others anti-clockwise. So choose the clockwise or anti-clockwise based on the design of the cutters. after you select this, the rotation of the cutter, go to select or to get a 0 point for z-axis. So 0 point for z-axis, there is several ways to get. First way, either you raise the carriage up to uh, the cutter and make a paper between them when the paper is not free for movement. So this is 0 point. When the paper is in touch, you can't move it. So this is not 0 point. So this is the first way. The second way, make a gap between the rotating cutter and the workpiece and start move up the workpiece by using knee elevating handle. Don't use auto movement as a first user, because you will cause damage for the cutting tool or for the workpiece that you are going to machining. So use the manual. Then when you rise slowly up to they start touching each others. If you feel there is a vibrations or there is a sound due to the touching between them, stop rising and go to the screen, reset zero axis to the 0 point. Then after that you will start feeding the workpiece to the required size that you are going to machine. So as a first user for this machine, don't go more than 0.5 mm per one feed. So feed each time by 0.5 mm. For example, if you want to machining 2 millimeter, so you must do it 4 times each time by 0.5 mm. So feed the workpiece in Z axis by 0.5 mm. Then move the table right and left up to finishing cutting these layers by 0.5, and repeat this same process until you get the required size. So if you want to get smooth surfaces, you can repeat it twice without feeding. So this is a way for getting zero axis. So this is the most important step in machining, is the zero. How to get the zero? If you can get the zero, so it's easy for machining for different type of milling operations. So move the table after you feed. Here in this video, he feed it by 1 mm because he was an expert, so can make the feed rate by 1 mm. But as the first user, don't go more than 0.5. So then stop the machine when you get the required size for the machining. This is a way for machining automatically. So just engage the auto machining and do the same way. Select the zero direction and Y direction. Okay, please keep watch this video. Okay, guys, do you have any question? If you have no question, I will show you another video regarding this lab.